Hi everyone. In today's lesson, we're going to talk more about different factoring techniques. Yesterday, we spoke about GCF. GCF is still always your first step of factoring, but you may have another factoring technique that you can use. And the one that we're going to introduce today is something called DOTS. DOTS is something that we can use when we have two terms and we have a difference of two squares. So today we're going to focus on GCF potentially being first, followed by dots, or simply no GCF and just dots. So let's go through some definitions first, and then we'll get into some examples. So take a minute, pause the video, and jot down what we have here, and then hit resume when you're ready for me to go over it. Okay, so dots. Dots stands for difference of two squares, but more specifically, they're difference of two perfect squares. So what is a perfect square? Well, a perfect square is a number that is the result of two of the same numbers being multiplied together. So what could that look like? Well, the first perfect square is really 1. Why? Because 1 times 1 gives me 1. The next perfect square would be 4, because 2 times 2 gives me 4. 4 is the result of two of the same numbers being multiplied together. 1 is the result of two of the same numbers being multiplied together. The next one would be 9, because 3 times 3 gives me 9. Then 4 times 4 gives me 16. 5 times 5 gives me 25. 6 times 6 gives me 36. 7 times 7 gives me 49. 8 times 8 gives me 64. 9 times 9 gives me 81. 10 times 10 gives me 100, and so on, right? I could keep going. 11 times 11, 12 times 12. So this perfect square list is just these numbers here, right? The numbers that are the result of two of the same things being multiplied together. So when we factor using a difference of two perfect squares, we're going to need to be able to recognize what those perfect squares are. Now, we could also have perfect squares that are letters. So x squared, or a squared, b squared, whatever letter you want to choose, will be your first perfect square that's a letter. Why? Because it's the result of x times x, two of the same things being multiplied together. So x squared times x squared, remember we keep the base and we add the powers. So your next perfect square will be x to the fourth. Now if we keep going, x to the third times x to the third. Remember, keep the base, add the powers, it would be 6, not 9. X to the fourth times x to the fourth, add them, we get x to the eighth. X to the fifth times x to the fifth will give us x to the 10th. Remember, we add the powers, and so on and so on. So this would be the list of perfect square variables: x squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th. So we should notice a pattern about all perfect squares that are letters. These exponents, 2, 4, 6, 8, 10, are all multiples of 2. So if you want to write that down, exponents will be a multiple of 2. Okay, and if I had asked you what thing times itself gives me x squared, or what thing times itself gives me x to the fourth, what's the relationship between these exponents here and the thing that's being multiplied twice? Well, look at the exponents. Can't you see here that x squared times x squared gives me x to the fourth, x to the third times x to the third gives me x to the sixth, and look at the relationship. 4 is your exponent, and then 2 is your power. 6 is your exponent, 3 is your power. 8 is your exponent, 4 is your power. 10 and 5. So you should be noticing that these exponents here are half. And all this stuff is going to come into play in just a couple of minutes. So I think we're ready for some practice problems. Okay, so let's just say I ask you to factor x squared minus 81. We would obviously use our flowchart and see if I could factor by GCF first. And I think that's not possible because there's a number here and a letter here. There's nothing in common that I can divide them out by. So I must now decide what is another type of factoring. And this is a difference. Difference means to subtract, so there is a subtraction sign. So it's a difference of two perfect squares. The x squared is your first perfect square, and the 81 is the second. And the way that we factor by dots is we do two parentheses. And in the first spot of the parentheses, we're going to put the square root of x squared. And in the second spot of the parentheses, we're going to put the square root of 81. So you want to think to yourself, what thing times itself gives me x squared? And that is just x. So x times x goes there. And then you say 81. What thing times itself gives me 81? You should be saying 9. So 9 times 9 is 81. And then since we need to multiply to a negative number, we need a positive and a negative. You theoretically could have put the negative first and then the positive. Either way, it wouldn't matter. Okay, what about example number 2? What if I gave you 81 minus x squared? So again, very similar, but this time I've switched them. So 81 is your first term and x squared is your second term. Still a difference of two perfect squares. So we're going to do the two parentheses. Inside the first parenthesis, we're going to put the square root of 81. And inside the second parenthesis, we're going to put the square root of x squared. So the square root of 81 is 9. 9 times 9 is 81. The square root of x squared is x and x. And again, we need to multiply to this negative number here. So a positive and a negative will do that. So similar question, except they're reversed. If the x squared comes first, then the x comes first. If the 81 comes first, then the 9 comes first. All right, so that's a basic dots problem. All right, what if I make it a little bit harder? What if I give you x to the fourth minus 16? So we still know that there's no GCF because we have a number and a letter. It's a difference of two perfect squares. So the first perfect square is x to the fourth, and the second perfect square is my 16. So again, we're going to do the two parentheses, and then inside the first parenthesis, we're going to put the square root of x to the fourth, and inside the second parenthesis, we're going to put the square root of 16. So remember, perfect square variables have even powers. So since this is even, or a multiple of 2, when we take its square root, we're just halving the power. So half of 4 is 2. So x squared and x squared. And then the square root of 16 is just 4. And don't forget that we need a plus and a minus because a positive times a negative is a negative. Now this one's tricky because I want to draw your attention to this. Do you see that this is another dots? This is another difference, meaning subtract, of two perfect squares. So we can actually extend this one in another set. So we take the square root of x squared, that goes in the front, so that's going to be x and x. And then we take the square root of 4, which is 2, and that's going to go here and here. And we need a plus and a minus. Now, all you have to do with this piece is just bring it down. So this piece is x squared plus 4. And this is your final answer. Now, some of you may be thinking, well, why can't I break this down more? This is a perfect square and this is a perfect square. Well, the reason why you can't is because this is a sum of two perfect squares. So this is not a difference. And because it's not a difference, we cannot factor it. So can't be factored. So please be very, very careful about that and make sure you get that note down. Okay, let's try another example. We'll call this example 4. So what if I give you 4x to the 10th minus 36? So it's a difference. And 4 is a perfect square, and so is 36. But what you want to be very careful about is that there's actually a GCF here first. We can divide both pieces by 4. So if there's a GCF, you have to take it out first. So step 1 is GCF. Take out a 4 followed by an open parenthesis. 4's cancel. We're left with x to the 10th. And 36 divided by 4 is 9. So we've done GCF. Now we need to check this second parenthesis in here and see, is this a difference of 2 squares? And it is. So this is dots. Step 2 is dots. So we need to break this down into 2 parentheses. And we ask ourselves, what is the square root of x to the 10th? And that's going to go in the front. Now remember, it's always half. So this is just x to the 5th, x to the 5th. And the square root of 9 is going to go in the second parenthesis, which is 3 and 3. And again, we need a plus and a minus and a 4 in front. And that's it. That is my final answer. This is a good example of GCF first, then dots. So always be careful checking for that GCF. Okay, I have one more problem. So we'll say problem number 5 is 9x squared times x plus 7 minus x plus 7. So you should remember this type of thing from yesterday. This is GCF. We could take out this x plus 7 that's in both. So we're going to do GCF of x plus 7. We're going to divide both pieces by x plus 7. We put the GCF on the outside, followed by an open parenthesis, and then we divide. So these two divide here, and they cancel. You're left with the 9x squared. Now these two cancel, but anything divided by itself is 1. So it would help maybe to put that 1 in front so that you don't forget it. So now we have 9x squared. So now let's see. Here is another dots, difference of 2 perfect squares. So we're going to break this down into 2 parentheses. What thing times itself gives me 9x squared? You should be saying 3x and 3x, or the square root of 9x squared. What thing times itself gives me 1 is nothing other than 1. And then we need a plus and a minus. And then don't forget to bring down that x plus 7 in the front. And that is your final answer. So we did a GCF, and then we did a dots again. All right, that's it for today. If you have any questions, please let us know, and we'll see you in class tomorrow. Have a good night.